Um, Hello everybody. Today we're going to be talking about the properties of logarithms. So, of course, before I begin explaining what do you mean by the properties of logarithms, I just want you guys to just think to yourself, what does the term properties mean, either in the real world or mathematically? Skip the of here. I mean, like, just, word to connect to other words. And of course, logarithm. So maybe think back to your previous knowledge, what you know about logarithms, maybe either in the real world or mathematically. So also connect the two properties of logarithms. Connect properties and logarithms together, either in mathematically or in the real world. So that's something I just want you to think about, of course, before any video. Just think about it. The title, like, what does it mean? Okay, so now let's actually get into the properties of logarithms. So first of all, just some, let's just say key sort of key, you know, let's just say concepts in logs. So something to just keep in mind here, first of all, a logarithm, if we have a logarithm to some base, we can just say this is log base b of c equals to uh a, and it's sort of like, how can we convert a logarithm to like an exponential form? Like, what if you were given what if you were asked, like, put this in exponential form. So what do you do? Well, we know that our base here, we take our base, we put it to the power of what our whole log sort of expression is it's equal to, and then we equal it to this. So the correct answer would be b to the power of a equals to c. Now, I want you to think here. If my explanation did not make sense, just look at where I move things around. You put the b here to the power of a, and we put that equal to c. B to the a, put that equal to c. Okay, let's try another one. Log base. Let's do some real sort of thing here. 2 of 5 equals to 30. Or sorry, no. Log base 2 of 32 equals to 5. So, same thing here. Put, let me write orange arrow here, that makes more sense. Put this in exponential form. Okay, so using the sort of rule that I did, I just want you to sort of, try this on your own. Use it, just rearrange the pieces. These are each separate pieces, just rearrange them. Okay, you should have gotten 2 to the power of 5 equals to 32. Now, no, I'm not making this up. Log base 2 of 32 actually equals to 5, because when we exponentiate it, 2 to the power of 5 equals to 32. Literally, 2 times 2 times 2 times 2 times 2, that equals to 32. Do the math. That's correct. So this just sort of illustrates sort of the connection between the two, I would say, perhaps. So that's sort of the key concept in logarithms. Now another thing keep in mind here is, what if you were given something like this? like log of something, log of x, for example. You're probably like, where is our base? Base. So that brings up a good question. Well, if we were given log of x, we automatically assume, like, if you think about like, for example, we have a square root, it doesn't show the 2 here for the index, it's just square root of x. Like, if we see this, it doesn't show the 2 in the index to indicate that it's a square root. We just automatically assume that this is the square root of x, right? So just sort of we assume this way in logarithms, just erase this here, that in the world of logarithms, we assume that this is always logarithm log to the base 10 of x. So that literally equals to log to the base log of x. Okay, and you're probably like, can we exponentiate this? Yes, we can. Same rule applies. 10 to the power of log of x, that equals to x, right? Because the 10 and the log cancel, and we get x equals to x, meaning that it's a true statement. Think of it this way, right? Since we know that log of x equals to log base 10 of x, we can only just do log of base 10 of x equals to log base 10 of x and exponentiate it. 10 to the power of log base 10 to the power of x, right, equals to x, right? So if our base here for the exponent and our base here for the logarithm are the same, they will cancel. So that also is a key concept, just to sort of know if we have a log in the exponent, what do we do? So that's why the point of the concept of turning it from exponent to logarithm is super important. Okay, so the next sort of concept, by the way, if you like programming, or if you like, for example, Java, for example, if you are given some logarithm, just fun fact here, that's right. Fun fact, I know. Fun fact. When we see like a log in Java, that actually is assume base 2. So not base 10, it's actually base 2. So that's sort of interesting to think about. But of course, when you're in math class, it's base 10. Or in a science class even, base 10 as well. Just pointing that out there, but don't let that confuse you. Okay, another one now we're going to talk about is the properties of logarithms. Now this one's sort of the big one. Properties of logarithms. So let me just erase this and make this an entirely new thing. Properties are of course fall under the key concepts category. Really, they do. So now let's just write properties of logarithms. So, there are a couple properties I'm going to cover today. The first one is, what if we had something like this? Log to the base, let's just say, I don't know, log to the base, y, something like that, of x to the power of, I don't know, c, right? And it's asking us to sort of simplify, right? I'm sure you've heard of this term a lot throughout your maths sort of academic journey. Simplify, that has a lot of meanings to it. So this also just brings our property here. So if we have log to the base of something, this of here, if this of has an exponent, then it gets moved to the front and multiply. So this is literally the same thing as c times log base y of x. Same thing works here. If we have just log of x to the power of c, keep in mind these are no defined, these are variables. This works in all cases. So we have log base x or log of x to the power of c. Same thing here. We will have c times log of x. Now you're probably wondering, what if I had like a question like this? Now this is so I'm just pointing out sort of a common question. Like, what if we had something, and we're gonna dive deeper into this question as we throughout this video. Like, what if we get something like this? Simplify like log of 32, for example. Now, there are many ways to do this. Now, of course, I'm going to show the one way using the property that I just talked about, which was the like if we have the exponent in the of, we can move that to the front. So, what do I mean by that? We know that 32, as discussed earlier, is 2 to the power of 5. So we can rewrite this to log of 2 to the power of 5. Now, since we are of here literally has an exponent, we can move it here. So literally log of 2 to the power of 5 equals to 5 times log 2. Now you're probably wondering, what if I just had log 2 and it asked me to simplify? Well, we know that 2 equals to 2 to the power 1, so literally a 1 here. So it will just be log of 2. You cannot simplify any further. So really, when it asks you to simplify, there are many ways to go about it. Obviously, your teachers will probably talk about this. Uh, Maybe they probably will be more specific, like simplify using some certain property. So, because you can go many ways about this. So that's the exponent sort of property. And that is, important as well. So now another property here is log of AB, and you can write this as A times B equals to log of A plus log of B. So going back to our point here of log of 32 and it asks you to simplify, you can literally just write it as log of 16 times 2, and that will get a log of 16 plus log of 2. Or even, you could do it this way, like log of, let's think here, like you could have, for example, log of 9, and you can just, that would equal to log of 4.5 plus log of 2. And then you can simplify log of 4.5 even further by getting log of 2.25 plus 2, then 2 log 2, right? Because this brings up another question. If we have like log of 2 plus log of 2, same thing like in algebra, that's just equal to 2 times log of 2, right? Like x plus x, that equals to 2x. So that's basically it in our of. If they multiply, we'll just expand it using the addition, right? Multiply and add. Now, hopefully you're sort of getting like, oh, is the next property what I think it is? Well, hopefully you're thinking, sort of in the right lines here, the right sort of idea, because it's sort of common sense, maybe. if you guys have common sense. I hope you guys do. You guys do. I'm sure you do. So, um, if you have, for example, log of a over b. So instead of multiplying, we're dividing. Well, then we would subtract. So literally, if we have, like, for example, so that's why if we get simplify, like if that same problem of like simplify log of 32, this is just an example, by the way, same properties are applied here. Then you can literally just write it as log of 64 over 2, right? And that's the same as log of 64 minus log of 2. So there are many ways to go about simplifying this. And then what? Log of 64, that's the same as 2 to the power of 6. So then we get 6 log 2 minus log 2, and you can go get 5 log 2 or log 32. So, sort of, I know, I'm just sort of explaining here. It's literally we are dividing and we are subtracting. Dividing, subtracting, multiplying, adding. Easy sort of to remember that. Now, some other things, like some example problems that I'm just going to talk about here. In terms of properties of logarithms, like what if it asks us to specifically, in this case, there's going to be like, not like numerical value, we're going to deal with variables on this one, like what if we get a problem like this? Expand log of 2x, right? And we can even make this fun. Log base 3 of 2x. Expand it. So we can put it as, remember, hint, okay, just write hint here. Remember, log of AB equals to log of A plus log of B. Same thing applies here. So in this case, who's multiplying with x, so we can write it as log base 3 of 2 plus log base 3 of x. Done. Now, of course, we see this 2 here. You could literally, for example, find the square root of 2 and expand this even further. But no, this is the correct answer. This is all you need to do. Don't make this more than it needs to be. This is the correct answer if it asks you this. Man, I'm trying to erase this thing. I can use the little eraser here. Go old fashioned. So yeah, it's pretty straightforward from here. Now, of course, like if we get another type of problem, I just brought up the square root. I brought up the square root today, so that raises another question, I would say. By the way, all my videos are like completely like, there's no script for this, there is no plan. I am doing these completely just out of, just my mind here. So that's why things may seem out of order. Anyways, so what if we have something like this? Log, expand, log of 6 root x. Now, you may think, right? Log AB, right? We would do log of 6 plus log of root x. But when we have the square root of x, you know that that's the same as x to the power of 1/2, right? So then this would be log of 6 plus log of x to the 1/2. But remember, when our of has the of, I mean like this, has an exponent, we bring it to the front. So then we would have log of 6 plus 1/2 log of x. So this would be the simplest form in terms of what we, of course, we could even expand it further. Like we could do log, right? Remember log of 6, same as log of 3 times 2. So we get log of 3 plus log of 2 plus 1/2 log x. But no, keep it, like if you have an integer value, just keep it how it is unless it has an exponent. Because that really, you can go many ways here. Then we can go 3, right? Log of 3, you can do log of 1.5 times 2. And we can go like log of 1.5 plus log of 2. So literally, we can go many ways here. Then we can even simplify this further. I'm not going to do that. Like log of 0.75 times 2. I don't want to go too deep into this, but yes, that brings up another sort of question in terms of the square root. Sort of, that's really the main idea. I don't know why I made it all like, oh, 3 log of 3. We can really simplify it. Like when it says simplify, I'm just gonna erase the whole thing here. When it says simplify, it usually be like there's supposed to be like you should not do like you should not have an answer like log of 0.0045 plus like etc plus like log of 7 plus log of you get the point. It's supposed to be like, for example, if you have like log, if your answer is like log of 5 plus log of x, right? Keep log of 5 how it is. Of course, with x, you could even, let's think here, what can we do? We can literally do log of 5 plus log of x over 2 times 2. We can get log of 5 plus log of x over 2 plus log of 2. Then log of x over 2, remember log of 5 plus log of x minus log of 2 plus log of 2. And you get log of x again. So in that case, this. So that's sort of just addressing the concern, like when it says simplify, what does it mean? Or like expand. When I said simplify, sorry, when I said like simplify, I meant as in like expand. Like expand the logarithm is the proper term to use. Now let me stick to the proper terms here. Sorry. Like what if we get condense? Now condensing is not like that where you can go many ways. Condensing is much more straightforward. Like condense uh log of 8 plus log of 7, or so yeah, or we can just do log of plus 1/2 log x. Okay, so condense meaning we put it back into like condense. What it means by condense is put back into single log. That's what it means by condense. So basically, we would put this as log of 8 plus log of x to the power of 1/2. And remember, when we're adding, we multiply. So this would be the same as log of 8 times x to the 1/2. And what I would even do is put that as log of 8 root x. Because this is, of course, the original form. So that's condensing, really, for you. Now, there are, of course, like many condensing problems. Now, going back to just logarithms itself, the properties are not incredibly, let's just say, properties, you can go either way with them, like when, especially with expanding, but usually, like this one, you can go like multiple ways. So I would probably say on this one, just, check, like just first look at the problem, and check if it like specifies, like, specifies at as to like to what extent, right? To what extent? I know my writing is all over the place. So that's basically it for expanding. I know I talked a lot about it, but yeah. But condensing, of course, is straightforward. Condensing, straightforward condensing here. Uh, Condensing, I would say, is more straightforward, as usually they will want you to put it as one single log. So that's basically it. This was a lot of stuff, probably for you to process, but hopefully you write down in your notebook, like all the information you need. This is basically it. You are set now. Of course, for logarithms, this video did not cover graphs of logarithms or like exponential graphs, but we will cover that in another video. But in terms of logarithms itself, you should be set. All right, see you on the next one.